Okay, so it's time to start. Very happy to welcome all of you. My name is Katrin Weber. I am Research Manager at Sintef Energy here in Trondheim, and I'm very happy to host today's webinar on biochar and urban green spaces. Before we start our actual session, I would like to take a few minutes to say something about the Nordic Biochar Network as the organizer of this event. We are fairly young. We have been initiated around 2 years ago and officially founded in December of last year. We work with promoting research and education around biochar. We want to improve the dissemination situation in the Nordic countries around biochar. We work towards facilitating and collaborating with different actors in the Nordic countries. So we would like to promote collaboration and cooperation between researchers and different stakeholders, for example, producers, users, and also policymakers. The network is registered as an official association, which means you can sign up and become a member. As a member, you have the option and also the right to influence what the network works with. The membership is always personal and it's free of charge. In addition to currently 75 members, there's also some people who have put a lot of effort and time into the network so far. You probably know, or some of the faces are probably familiar to you. Some we already, you can also see in the video and the webinar today. So very happy and very thankful for my colleagues and friends who've put so much time into getting the network this far. A bit about this event. It was actually planned that we would have a physical biochar conference this year in Norway. But as so many things this year, that didn't work out. So we decided to launch a webinar series. So this is going to be a bi-monthly event. And we plan to keep it going open-end as long as we run out of either people who want to present or people who are interested in listening. So if you have something interesting to present of your biochar work, don't hesitate to contact us, because then you will contribute to help keeping this webinar going as long as possible. As for today's event, there's always a sign-up required. This is a bit for organizational reasons, so we know about how many people might attend. We announce the webinars on our homepage. Our members will also get information via the newsletter or in our LinkedIn group, and we also use our partner networks to spread information. Now I've already said too much because you didn't sign up to hear me talk, but to hear Anne-Marie talk. So I'm very happy and very pleased to welcome Anne-Marie Fransson. Anne-Marie has a PhD in plant ecology from Lund University. She has 16 years of experience as an associate professor at the same university before she moved to the Swedish Agricultural University, where her research focuses on urban plant ecology. So she works with improving conditions for vegetation in urban environment, and to create a higher biodiversity. Her work is very practically oriented, and today Anne-Marie is going to give us a bit more insight into biochar in urban green spaces. A bit from the organizational point of view, you will be able to ask questions, but you have to do so in the chat. So during the session, you can already ask questions in the chat that we will then ask Anne-Marie afterwards. Okay, so I hope you are as excited as we are about the biochar and today's webinar. And then I welcome Anne-Marie, and I would like you to share your screen maybe, and yes, enjoy the webinar.
Thank you very much, Katrin. Thank you for the very nice introduction. I'm just gonna share my screen. Okay. So, yes, my name is Anne-Marie Fransson, and I've been working with biochar since maybe 2012, 13. It started with me with Björn and Bren in Stockholm asking me to sit in on a workshop where he was going to decide if he wanted to try biochar in his in the urban trees in Stockholm. So maybe as many of you know, he did, And he actually created the biochar market in Sweden, more or less, from that. So, and I've been kind of following that development, and also started experiments with biochar in urban green space. So currently I'm in a project that's called Rest till Best. We don't have an English translation for that, sorry. But the aim is to look at biochar as a solution and a product for the circular and vital society. And we have a homepage that is actually translated to English. There's an English version of it. So you can go there and watch. So the purpose of this project, it's a Vinnova funded project, I should say. And we try to develop solutions for managing organic residues like park and garden waste, sludge, algae, and seaweed, and create a valuable product, biochar, while minimizing environmental and climate impact, and a carbon sink is established. And here you can see the partners in the project. And we have focused on the urban area, you can see, because we think that there's a possibility, there's a market actually developing, as I said, in Sweden, and that can help creating a market and maybe pressuring the price for biochar so it can be used in other areas as well. Because in the urban areas, there's a will and a ability to pay for biochar. So this is how the project looks like. We have the whole chain from the waste production, or the municipalities with a problem of getting rid of residues and wastes. And then we have a pyrolysis unit that we use, and the biochar that is produced is tested in different urban applications. But also the pyrolysis plant is connected to a district heating system. So they have carbon negative district heating. But we also test how to remove cadmium from this in this process. So again, the project overview, we look at pre-treatment of feedstock. How do you make seaweed to a product that is possible to run in a pyrolysis plant? We look at the process parameters in the pyrolysis. How much do we need to feed the plant? What are the energy output from these different materials, and how much cadmium is removed? We look a little bit at the biochar properties. Probably we're going to do that more in the next step of the project. We look at the system analysis, the mass balances and energy, and the effects of this whole project on the society. We also have field trials and growth tests in different areas. And that's what I'm going to talk about more. Next step, we're also going to look at the logistics and the biochar treatment. How do we make the biochar, productify the biochar? Is that a word in English? Probably. So this is the plant. It's two kilns, one Pyrig 500 and one Pyrig 1500 at Skånefrö in southern Sweden. It's a small place called Hammenhög, and they are producing EBC certified biochar, and it's been up and running since the summer of 2019. So the larger kiln, the Pyrig 1500, it's in continuous production, and the Pyrig 500 is where we try new feedstock and make our tests. As I said, these are the partners. There are a couple of municipalities, Lund, Malmö, Uppsala, and Trelleborg, and research organizations, SLU University and RISE, but also some organizations like Scandinavian Green Roof Institute, and smaller companies like EcoBalance, EcoEra, EcoTopic, and VegTech is maybe not a small company in this area, but these are who we are. So back to my specialty, my part in this big project, that is looking at the biochar in the soil. This is a man trying to dig a hole in the soil in an urban, rather common urban situation. It's very, very compacted, and it's dry. The water is drained in urban areas, and it's usually quite a hot place for plants to grow in. So the conditions for the plants are not optimal, far from optimal. So that biochar can help with fixing some of these problems. So why do we want to use biochar in urban soils? For some of the systems, like constructed structural soils and rain gardens, that don't have any organic material and that shouldn't have any fine materials, biochar is vital for the function, because biochar can retain water for the plants. And despite the name rain gardens, these systems can become very, very dry. So the biochar improves the water availability, not only in structural soils and rain gardens, but also in most urban soils. It improves the nutrient availability, and it causes and creates a resilience against drought. And it can clean stormwater in stormwater management. And as a consequence, or it can reduce the risk of nutrient leaching from the systems. But it also, of course, creates a carbon sink, as you all probably know. And it might reduce compaction, so we don't need this saw to take soil samples anymore. And you do understand, of course, these soils are very difficult to grow in for the plants. So in this project, Rest to Best, we have tested a number of different vegetation systems where we had introduced biochar in different ways. So we have tested in urban trees, for example. We have also returned to old experiments and follow them up. We have tested grasslands, mainly urban meadows now. We haven't had time for lawns and road verges. We have made tests in green roofs, on a living wall, and in rain gardens and green-gray solutions, but also on football fields. One of the partners has a mission to try to build a system that can compete with these plastic football fields. We'll see how that works. One of the oldest experiments with biochar in urban areas is from Harhagsvägen in Stockholm, in Enskede. And these are the trees that were planted. They were planted in 2009 and in the winter in 2009 and 2010. And this was the first season, actually. So there's a test in this on this road. There is cherry, Prunus on a conventional street, and there is a control strip with conventional standard soil, that is the Swedish standard Arma and Arma B soil. And then on another strip there is this standard soil, same Arma B soil, and biochar, 50% of biochar, volume percent biochar. And there's also a strip where there's only gravel without any soil. And then there's on top of it, there's a stretch of lawn. So, and the results are like this. The green is control, the black is biochar, and the gray is gravel or macadam. So the biochar increased the stem circumference of the trees very much. There was a 35% increase in the growth due to the biochar. And this increase, this difference increased from 2013 to 2016. So still 6 years after the application, the trees in the biochar treatment grew better. We don't see the same result for the shoot length. It seemed like the shoot length is the advantage of the biochar in the shoot length has leveled off towards the end of the experiment. But the trees also got it wider, so the shoot length responded in the beginning of this test, at least. So the trees grew bigger, but they also, as you can see in this picture, this is from October, and the plants in the biochar hasn't dropped their leaves yet, as opposed to the others. So that's also an indication. That's an indication that this effect is due to high nitrogen levels. So when they get a lot of nitrogen, they don't winter that well. And we also could see cracks in the stems, actually. So we think that this was a nutrient effect. So we did test on the nutrient levels in the leaves. in 2016, so 6 years after the establishment. And we can still see that the trees with biochar had higher nitrogen levels, nitrogen concentrations in the leaves than the control plants. So at the establishment, the trees were watered, and in the water they had nutrients. We don't see the same effect on phosphorus, though. This result here is not significant, but if we remove one outlier, we have a significant result for the phosphorus as well. And then we can say that the trees with biochar had less phosphorus in the leaves than the control. And that's probably a dilution effect, because the trees in the biochar treatment had grown better, so the nutrients, the phosphorus was diluted. So we also did an experiment in Malmö in 2014. This wood-like park that was established, and we tested biochar in one part of this park. So 10% biochar was added, and on top of this we had 5 centimeters of green compost, and we have a control without biochar. And in this picture you can see the measurements from the 25th of September in 2018, so 4 years after the establishment. And we measured the growth of 4 species, Quercus petrea, Prunus sargenti, Carpinus betelus, and Prunus cerasifera. It's oak and 2 Prunus species, and what's that in English? Avenbok. I can say them in Swedish maybe. So it's bergsek, körsbärs, nu ska jag se, bergskörsbär, avenbok och körsbärsplommon. So biochar increased the basal area, but there was an interaction with the species. So, and we think that the Carpinus betelus is outcompeted by the other plants that are growing very well. So this is a satellite photo, and this is the same place, a picture taken by a drone in last summer, and here you can see where the biochar is added. So I think we can see the effect of biochar from space. We also started an experiment in Malmö where we inject biochar to existing trees. If we want to use a lot of biochar in an urban environment, we have to add biochar to the existing green structure, because to only add it where we make new plantations wouldn't be such a big, it wouldn't require that much biochar. So we think that we have to try to improve the soil for the existing plants with biochar, and also a lot of the trees and the vegetation in urban areas look like this on this picture. They don't feel very well, so they really need an improvement, that the soil will be amended and improved in different ways. So there's maples, and we have 4 treatments that are done. We have a control, we have a decompaction, and then we inject biochar into the soil. And one of these trees that have been injected with the biochar will also be fertilized. So we have 4 different treatments, and we have done this, replicated this in 4 different blocks. And we will be following the trees during the last 4 years. So the treatment was done last year, like this. It's a high pressure air that is first just there's a pulse of air into the soil, so it becomes decompacted, and then after that biochar is added as well. So to the right you can see some soil particles that was flushed out of the soil, and you can see that the biochar is kind of coating the soil particles. And on the bottom right, you can see the hole of the from the instrument, and you can see some black biochar on top of the grass, but that's all. So we managed to inject 40 liters of biochar, but we had to make it quite to a fine powder. So we sieved the biochar that we had. And we have results from this year. We can see that there's a slight increase in organic content of the soil where biochar is added, but it's very low, so it's probably not relevant. But we don't know how the biochar has been mixed into the soil. So probably if we had hit the channels that the instrument made, we might have been had a higher organic content of the soil. And we can't see any effect on the water holding capacity either. But as I said, the biochar is not really mixed into the soil. But there we can't see any difference yet on the trees. And the fertilization is not done yet. So I expect that we will get a bigger effect when we do a fertilization as well. Yes. We also revisited another experiment that was established in March 2016. Linden trees planted in a clayey soil just outside Lund. And the soil is mixed with 10 and 50 volume percentage of biochar. And as you can see in the picture, the trees received irrigation during the establishment. So they were irrigated and fertilized. And we have the three different experimental setups like this. The trees are separated in 3 different plantations. And we have separated the soil with big sheets of steel to avoid soil mixing. And we also had different top layers. One is the G is permeable. It's a gravel that where the finest particulates have been removed, and the EG is where the finest particulates are still present. And surprisingly, it seems like the plants that where the gravel the top layer has the finest particles present are doing better than the others, actually. But we could see that the biochar has an effect on the trees. And I was a bit surprised by this, because I thought that they wouldn't benefit from the biochar in this clayey soil. But the preliminary results, and these are very, very fresh, they are that the biochar treatment has increased the stem circumference of the trees here, and also the shoot length. We still have to look at the nutrient levels in the leaves to see if they have if it's a nutrient effect, or maybe it is a soil structure effect. Maybe we have to look into this. And this is how the trees looks like now. We have also tested green roofs. So biochar was added to one set of old roofs and 2 sets of roofs at establishment. And we used a gradient from 0 to 25 volume percentage of biochar. So, and we can see that if we use up to 20% of biochar in urban roofs, we can't see any negative effect on the vegetation. But at 25% biochar, the vegetation composition changes, and we begin to see stress symptoms. And we can also see that the leaching of nutrients, nitrogen and phosphorus, is reduced as 20% biochar. We also have another gradient where we grow plants, green roof plants, in a gradient from 0 to 25%. And here is a picture of 0% biochar, 10% biochar, and 25% biochar. So we tested the cover of the vegetation. We took photos of the vegetation, and then we looked at how much of the surface that was covered with vegetation and how much was bare soil. And in 2019, in April 2019, the vegetation was fertilized. So in the beginning, we can see a negative effect of the biochar, probably because the nutrient, the nitrogen, is restrained to the biochar. And then this effect is reduced or disappears. But then when the vegetation was fertilized, we see this effect again. But the effect is reduced quite quickly. And then in July 2019, the situation became a bit difficult for the plants. It was warm and it was dry. And then we can see that actually the vegetation that had 5 and 10% biochar didn't grow better than the control and the vegetation with higher biochar content. So we did another analysis of the photos. We looked at the reddish leaves. So when plants become stressed, they produce a red substance that reflects sun, for example. So then they can tolerate the stress a bit more, like stress like drought, for example. And we could see that in 2019 in July, we could actually see that the plants with the highest biochar content had higher and more reddish leaves than the other plants. So this is how that looks like when we had the frame, and we took pictures and tried to analyze the color differences. We also have looked at plants on a living wall. There's a biochar gradient of 5 to 50%. And we looked at the plant performance. So that's a visual estimation of the vitality and the aesthetic appearance. So yeah, so it's we divide it into 4 different classes, 5 different classes, 0 to 4, where 0 is completely dead and 4 is no signs of reduced vitality. So we can see that there is a pH effect, because plants adapted to low pH did best at low biochar levels. So we are processing this data, and we have taken samples for nutrient analysis, and we're going to do a color analysis on these plants as well. So here you can see the entire wall, and here are some examples of the plants growing at different biochar levels. And maybe you can see in the middle we have lingonberry on the wall, and it's actually growing very well. It likes the environment. We also look at blue-green-gray systems. That's a combination name for different types of rain gardens. So the aim is to study the plant response to the water supply in these kinds of systems, with and without biochar, and to test the performance of these biofilters. So we have a gradient of water supply to the different rain garden plantations. There's a different relationship between the surface runoff and the area of the rain garden. So we have 3 different types of blue-green-gray solutions on the site. One more traditional rain garden, where the water is and enters the system at the top and then filters through the material, and then might be let off in the bottom. And then there's another where the water is added from the bottom of the tree pits, and the actual plantation is kind of watered from below. And then we have these tree pits according to the Stockholm model, where we have trees growing in hard covered surfaces with biochar and macadam and compost in the planting soil. But we don't have any results from this experiment yet. We are collecting data now, and it was just constructed, so we're going to follow this for a couple of years now. This is how a rain garden looks like when it's raining, and it's supposed to look like that. some of the area in the rain garden is supposed to be flooded to retain water and store water during the rain events. And then the water will infiltrate into the substrate and be cleaned, more or less. We have also looked at urban meadows. We tried to. We were going to look at how the biochar affected the biodiversity in the urban meadows. So we established urban meadows with and added biochar in the process. But we could see that the biochar actually had a negative effect on the amount of species that was established, but also on the vegetation cover here. So the limits to these applications is that we can't extract more biomass than is sustainable from the system. We can try and recirculate the waste from the cities, but there's a limit to how much biomass that can be produced in an urban environment. And biochar also decreases the albedo, so the soil temperature might increase when we add biochar. And there's a conflict between biochar and bioenergy, of course. But we also get variable growth responses. And we are not really completely sure about why this is happening. But there's also a question about the mechanical stability of biochar in the soil. Will it stay in the rain gardens or will it be washed away? And that's also related to the working conditions. All of you that have been trying to mix biochar in soil know how you look afterwards. You become quite black. And it increases the pH, and that's negative for some of the plants. So that was all that I wanted to say. That was a bit longer than 30 minutes, perhaps, but yes.
Thank you very much, Anne-Marie. It was very interesting. I think urban green spaces is something that we all can relate to. So we do have some questions. Julia, you want to take over with the questioning?
Yes. Thank you very much, Anne-Marie, for the very interesting presentation. It's really good to see all of these practical applications. To all the participants, if you want to ask questions, you can write in the chat, and I will take care of bringing your question to Anne-Marie. There is Noelle who asks, what kind of biochar did you use? So I think she was referring when you were talking about the tree plantations.
Yeah.
But perhaps you can give an overview of if you use different kinds of biochar in the different experiments, and if you think that changing the type of biochar would have an effect on the plant growth.
Yes, I think. Yes, I'm sure. I know it will. So in the tree experiments in the old Herhagsvägen, it was wood biochar. And it was a fine pulverized, so to fine particles. In the park in Malmö, it was also wood, but it was chunks of wood biochar more. So I think both the quality, the feedstock, and the actually the particle size is probably important. In the Lund experiment in the clay soil, it was also chunks, but a range of biochars. In the green roof experiments, we have used, and the green wall experiment. Oh, I should have said this when I was talking about it. Sorry. We used bioagro pellet biochar from this project, Rest Best. So it's the biochar that is produced at Skånefrö's plant in Hammenhög, and it has a higher pH and a very high surface area, we think. So it's it might actually retain water too much, so and hold the water so it doesn't become available for the plants.
So sorry, can I ask you, is this agricultural residues pelletized then?
Yes.
Okay.
Yes, it is. So Skånefrö is producing seeds, and then they get a residue like seed. What do you call it? Husks.
Husk,
and
yeah.
and weed seeds and different kinds of those things. So they pelletize that and make biochar from it.
Okay.
I don't remember if I forgot any. And the I don't remember what kind of biochar is used in the rain garden experiments. There are two different types of biochar. I think both of them are wood biochar.
We have also other two questions asking about how you pre-treated, or if you pre-treated the biochar before adding. For example, Anna asks if you when you talk about adding biochar, if you mean charged biochar, and with what substrate? Charged? I'm not sure what she means by that, but maybe you know. And with what substrate? And Igor also asks if you activate the biochar before adding it to the soil.
That's probably that's the same question. So charging or activating, it's when you add nutrients to the biochar before you add them to the soil. But no, we haven't in any of the cases, because I think that in my opinion, you don't have to. You can fertilize the soil afterwards instead, just as you would in any other plantation, and the biochar would retain nutrients. Yes, so we haven't done that because that would, no, we haven't.
Okay, that's just biochar straight out of the plant, let's say.
Yeah.
And speaking of the plant, there's Erlen who also gets back to your point in the conclusions about the conflict between biochar and bioenergy, and he asks how the gas is used in the Pyreg plant that you use for producing biochar.
It's used for the district heating system, so it's connected to a village district heating.
That means, I guess, you're not using it or considering its use for electricity production.
No, there's no electricity produced there. So it's connected to the grid, kind of.
Okay. I have one last question also from Erlen. He asks if you measure the water holding capacity of the green roofs at the high biochar additions, and how do you rate the potential of such roofs in stormwater management?
I don't have the numbers of the water holding capacity in the substrate, but it would increase. How I rate them as a stormwater management. Well, I have seen numbers that they can completely retain a 10 millimeter rainfall. But then there are kind of full. But I mean, that could be very important if you add that to all roofs. So you reduce the the amount of rainwater at the source, so to speak, and that could be quite important for the stormwater system. But I mean, for these extreme floods, they are kind of they have a very minor contribution.
Yeah, we would need many roofs covered in green and biochar
well,
to see an effect.
Yeah, but when it rains that much, it's just you have to have like dams and things like that. So, but it levels out the peaks.
Sure, it helps anyway.
Yeah, it helps.
So we have more questions coming in, and there is Turit who asks if you can think of a reason why the biochar addition to the meadows didn't work out that well, and you see actually a negative effect there.
Yeah, I think that looking at the vegetation that actually grew there, they were nitrogen fixators. So it might be that the system actually was already low in nitrogen. So when we added biochar, we actually created nitrogen stress. That's one reason. Another could be that we increased the pH. So it became less suitable for the species that we actually chose. And also that we use this the agricultural residue biochar, and which has a really high surface area. And that means that there is a lot of water that might be retained in the substrate that is not available for the plants. So we might actually have created a drier system initially. So
do you think perhaps in an application like this, it could be actually perhaps useful to charge the biochar then with nutrients, and so to limit this effect?
No, because I think that we were aiming to reduce the nutrient levels.
Okay.
So to get a better establishment. But I mean, if the nutrients levels already are low, then you wouldn't get that effect. Then you would push the system to a stress instead. So if you have a very nutrient-rich soil, I wouldn't add nutrients, but in this case, maybe yes. Okay. But the soil was very compacted as well, and maybe the biochar particles actually compacted the soil even more. I don't know. I have to look.
Sorry, one short question. The particle size of the biochar that you used in your experiments, what was that?
It was different in different soils. In Herrhagsvägen in the Stockholm, it was fine particles. In the injection, we also had to have fine particles, but then in the others, they were a range of particles from like in the Malmö Park system, they were chunks actually, and then it's like when we use these agrobio pellets, it's like pellet size to very fine particles. But I'm convinced that the particle size is important here.
Yeah, but so like, what do you think is like the way to go? Would be more finer particles so that there's a better mixing, or would it be more coarser particles?
I think that depends on what kind of soil you have and what you want. We have made some tests actually where we looked at the water holding capacity in biochar with a coarser material or the material when it came out of the production, and sieved, so the finer particles. And it seems like if the water holding capacity is better when you have a larger range of particle sizes, and that's probably logical. But then again, biochar can work to aggregate the soil, and then you probably would want finer particles. But I haven't found any research on that yet, actually.
Sorry to interrupt you, Anne-Marie.
Yeah.
We are almost out of time, and
Yeah,
there are more questions coming in. I think I will ask the participants perhaps to send their questions to me or to you in an email, so that those can be answered perhaps later on. I would perhaps close by this last question from Igor, who asks to summarize the conclusions. From your perspective, what is the most promising way to use biochar in an urban environment?
The most promising way?
Yes.
Oh.
The one you like best.
The one I like best. I think if you think about the largest carbon sink, I think we have to develop these applications where we add biochar to existing systems. So I think, yeah. And in these systems, the vegetation is not growing very well, or it's not very vital. So I think from the carbon sink point of view and the vegetation point of view, the highest potential is to use it in existing.
So like to decrease the stress on existing plants.
So then we would, we will get a carbon sink, but we would also get a more vigorously growing vegetation that also stores carbon. So, and we get all the positive effects from a healthier vegetation in an urban area, like people are feeling better, have a better health, and all those kinds of things. And we get shade and all these spin-off things. So I think that's
that makes the cities much more livable.
Exactly.
We all agree on that.
Yes.
Okay, I think we need to close now. It's 10, and we can perhaps conclude by saying that this session was registered, so I think it might be available.
We have recorded, sorry, Julia, we have recorded the session and we are going to make it available for you. So that you can also go back into the presentation and look at the answers that you may have missed. So there will be a way.
And perhaps mentioning the next webinar will come up in December again. And we will hear from a small Danish company and their technology for pyrolysis systems.
Okay, thanks, Julia. Thanks again, Anne-Marie, for the nice presentation.
It is very nice to
Thank you very much.
join.
Thank also to all the participants who joined today, and I'm looking forward to our next webinar in December. Have a good day and a great weekend, everyone.
You too, Catherine. Thank
Bye.
you. Thank you, everyone.